Okay, today we are talking about early space exploration. This is the second section. There are only 3. So that means hopefully middle to end of next week, we will be having the test over this chapter. Our objectives today is to explain how a rocket works, to describe the different types of satellites, to outline major events in early space exploration, including the space race. That was really a big thing when I was younger. So even though space exploration didn't really happen until the late 1900s, which was the late 20th century, technology that made it possible has been around since at least the 1200s, which would be the 13th century. And that would be rockets. A rocket is something that is propelled by the particles that are pushed out one end at a really, really high speed. Now, ordinarily, those have to have something to push against to push it up. It's that whole, Newton's law thing. Are we good? Where we think that they started was with Chinese. The Chinese used them for a lot of different things. They start in the early 13th century, so in the early 1200s. They used them against the Mongols when the Mongols were invading China. Well, the Mongols found these rockets to be very destructive, so they actually kind of stole the idea. And when they went to war with Eastern Europe, they used them in that war. Now, yes, rockets also have less destructive uses and uses that we still use them for today. Of course, they are still used for missiles and things like that, but the more fun things are for the fireworks. Everybody likes, well, okay, not everybody. I like fireworks on the 4th of July, okay? I do not like them at unplanned times, but I really love them on the 4th of July. And rockets are used to launch those fireworks, to get them up high enough in the sky where they don't hurt people. In 1687, Sir Isaac Newton developed the 3 laws of motion, which is what explains how those rockets work. What slide are we on, you guys? 5. Because it's not slide 5 for me, that's why I have to ask. Law 1 says an object at rest tends to stay at rest unless it's acted upon by an outside force. Okay, so if I take my little box of notes and I sit it on the table, it's going to stay there. It's not going to go, do anything unless something gives it the energy to do it. Okay, so if I shove it, then it will move. But if I don't, then it's going to stay there for forever and ever, right? Okay. Law 2 said that force equals mass times acceleration. All right. You know this if you've ever driven a car and tried to stop it. It takes much more force to stop a car or to stop something else that is going really fast than it does something that's just poking along, right? Or to stop something that's really massive as opposed to something that's really teeny tiny, right? I mean, if I had Megan and Andre, right? Oh, yes. If I had Megan and Andre stand up and I had them square off, and I had them push each other, try to push each other, who's going to win that? Oh, come on. Hello, who's going to win that? Andre, why?
Because he's bigger.
Because he's bigger. He has more force. Now, Megan may get a few pushes in there, right, Megan? You're not going to give up easy, are you? Okay. Okay? But, come on. Andre could just, just kind of flatten. Because he's so much bigger, he has more force. Right? Law 3, to every action there is an equal and opposite reaction. Now this isn't what it's talking about, but if I walked over and I just slugged or slapped Nicole for no reason at all, what are you going to do? You're going to smack me back. Duh. Right? That is not what it's talking about. But it works if you think about it. Okay? What it's talking about is if I sit on this desk is also pushing back on my butt. And that's what keeps me from hitting the ground. Right? Okay? This last one is the one we're going to use most when we're talking about rockets. It explains how they move in space. You have fuel in a chamber. That fuel is ignited. Because remember, let me back up. It explains how it moves in space because in space there's nothing for it to push against. To launch it, we put it on a launch pad. And when that force pushes on the launch pad, the opposite force pushes that rocket up. Makes sense, right? But once it gets away from the launch pad, what's it pushing up against? Especially once it gets into space where there's no air or anything in there. It's the fuel that's ignited in the chamber causes a little explosion. Okay, it's a pretty big explosion if you've ever seen a rocket in space. Okay, it's an explosion of gases, and that explosion pushes stuff this way, which pushes the rocket the opposite direction. Okay, it creates that pressure that forces the gases out of the rocket. Here's my rocket. My mouse is my rocket. Okay, let's turn it the right way. It would go that way. Yeah, that'd be right. Okay. Gas chamber would be in here. It would explode. The gas would be pushed out this way, which would push the rocket, because equal and opposite, push the rocket this way. Make sense? Okay. Now I gotta get my mouse back where it was. As those gases rush out the end, the reaction force of the gases, like I just said, the reaction force of the gases pushes the rocket forward. We call that particular force thrust. Are we good? Did not hear no, so I'm assuming that's a yes. The first rockets and most rockets that still use solid fuel, that fuel is gunpowder. Gunpowder is heavy, and the biggest part is that it burns really, really fast. So the rockets would run out of fuel before they would get high enough to get out of our atmosphere. Because it didn't provide enough thrust, yes.
May I use the restroom?
Not during class. I'm sorry, I'm not supposed to allow you to leave class. What time is it? What time are we done? I'm gonna let you out this one time. You need to take care of that before you come to class. Hurry up. It wasn't until the late 1800s, which would have been the 19th century, and the early 1900s, which it would have been the 20th century. Remember, centuries are one more than the year, 100 more than the year, right? So if it's 19, it's going to be 20. If it's 18, it's going to be 19. Like we're in the 20s now, but we're in the 21st century. What?
Scissors.
Yeah, middle drawer, I think.
Thanks.
These ideas were developed by 3 different people in 3 different countries, all kind of around the same time. And it was these 3 discoveries that made space exploration really possible. The first one was made by a man, I do not even know how to pronounce this last name. I think it's Tolkovsky, but I could totally be wrong about that. He was actually a Russian school teacher. I think that's kind of cool that a school teacher came up with this. He thought that instead, what rockets needed, instead of this solid fuel that they've been using, this gunpowder, they needed some kind of liquid fuel. Because liquid fuel will give you every bit as much energy, but it doesn't burn as fast. So it would give them a longer time to use that fuel. He also said that there would have to be a balance between the amount of fuel and the weight of the rocket. Okay? Remember, the fuel's heavy, but so are the rocket parts. So if you're running out of fuel, that means that you need to lighten the weight of the rocket. Does that make sense? Okay? So he is one of the first ones to come up with the idea of using multiple stages. So they'll have the one stage, it will take off with one stage, and when the fuel from that stage is burned up, that whole stage just falls off. And then they ignite the second stage. I don't know if you guys have ever watched the liftoffs of some of these rockets, but that's exactly what happens. They'll take off, and when they get to a certain height, the fuel in that particular rocket is done. So they hit a button at mission control and it drops off. And then you'll see it flare up again where the second section lights, it ignites, and they'll be pushed off a little bit farther. He had lots and lots of great ideas for big rockets, but hello, school teacher. He really never got to build one, which I think is really sad. Because I think that would have been awesome for a school teacher to have done that. Second guy that we need to talk about is an American. His name was Robert Goddard. He was an engineer, he was a professor, he was a physicist. And he's the one who is credited with creating and building the world's first liquid-fueled rocket. So, and this was about the same time as the gentleman in Russia was also thinking about that. He also liked the idea and decided that multiple sections is exactly what rockets needed in order for them to be able to go higher into space. And then there was Hermann Oberth. He was a German. He worked with the Nazis. He was a physicist and an engineer. And in 1929, he also built a liquid fuel rocket. He was part of the team that developed the V2 missile that was used by Germany in World War II against all of the Allies. Mr. Oberth, are we good? Am I going too fast? Are you guys okay? Okay. Mr. Oberth then defected to the U.S. and he became one of the leading scientists. I'm sorry, we missed somebody in there. Mr. von Braun was the one that actually led this team. He eventually defected to the U.S. He became one of the leading scientists developing missile technology. Then he joined NASA and he helped develop even more rockets, like Saturn V, which took the first men to the moon. We have been to the moon several times. I don't even remember the exact count. But there have been, I want to say, there have been less than 10 people who have actually set foot on the moon. All of them Americans. No, there are 24. 24 people who have set foot on the moon. All of them Americans, all of them male, all of them white. Because it was right before segregation was really, desegregation was really a thing, that we stopped the space program. An orbit, for those of you who don't know, an orbit is a circular or elliptical path around an object. So, if I'm walking in circles around these three lovelies, I am completing orbits around these three lovelies. Because I am completing a circular or elliptical path around an object or objects. I'm sure they love it when I orbit. Right? A satellite is an object that orbits a larger object. Yes? For the last question? Are we there yet?
It's at the end of
Are we there yet? Then you want to wait for it? Okay. A satellite is an object that orbits a larger object. He's larger than me, so if I was orbiting him, poor Andre, I'm really picking on you today, aren't I? Dude, you're taller than me. I can't help it. You need to be short, and then you can get picked up. If I'm just orbiting Andre than I'm a satellite around Andre. Our planet has a natural satellite. It's called the moon. At this point, all of you should probably go, duh, right? We already know that. Now we have lots and lots of man-made satellites also that orbit Earth. Lots of them. So why do these objects orbit our planet instead of just floating around all over space? I want you to answer that question. Why do you think these objects orbit our planet? Why do they stay in orbit around our planet? Gotta put something, Megan. Why do you think they stay in orbit around our planet? What do you think, Bree? Why do you think they stay in orbit?
The gravitation.
Gravity. Okay. Did anybody say something different? Really? Everybody said gravity? Dang, y'all are smart. Because that's exactly it. Newton's law of universal gravitation. That's the big official name for the law of gravity. Mask up. Thank you. Newton's law of universal gravitation. It explains that every object in the universe is attracted to every other object in the universe. The bigger the object, the more gravitational force it exerts. That's why my light here, it's toasty. It has, believe it or not, this light has gravitational force. Is anything really attracted to it? I mean, when I walk by, do I kind of go, oh, toward the light? No. Why? Because it's too little. That's why we don't have that effect on each other. I mean, come on. How weird would it be if we're walking down the hall and every time we walk past somebody, it's like, whoa, right? That'd be odd. Okay? Bigger the object, the more gravitational force. Our planet is pretty good size. So our planet has a big gravitational force, which is why we kind of caught the moon. And it stays in orbit around us. Newton came up with this with an explanation as to why things orbit or how we can get things to orbit Earth. He said, okay, it was his explanation. I never said it was totally 100% correct. All right, just letting you know. Because Newton says, if I take a cannonball and I shoot a cannonball at a slow speed off of Mount Everest or off of a high mountain, that gravity is just going to take that cannonball and pull it right back down to Earth. Now, it's going to go a ways because it's got a lot of force behind it, but eventually it's going to just come right back down to Earth. However, he said, if you shot a cannonball at a fast enough speed, then Earth would curve at the same rate that the cannonball was falling. So it will allow the ball to go into a circular orbit. And he also said if you shot a cannonball and you shot it too fast, then it would either go into an elliptical orbit or it would escape gravity completely and just shoot off into space. Okay, now, guys, a cannonball is going to burn up in the atmosphere before it ever gets to space. It's not made of the right stuff. All right. So what we really look at is that middle explanation there that says if you shot a cannonball at fast enough speed, Earth would curve at the same rate the ball falls. Now, remember that something wants to continue in the same direction until another force is exerted on it, right? So, when we shoot a rocket up, we shoot the rocket straight up. The rocket wants to go this way for forever, right? Right? All right. But Earth curves, and Earth's gravity will take that and go, like if this is Earth, we shoot this rocket up, the rocket comes up, and as Earth curves, gravity goes, nope, I need you to stay here, and pulls it back. And then the rocket's going to want to continue this way, but it curves, and it keeps being pulled back in. And that's what gives us our orbit. There are 4 kinds of satellites that we need to talk about. The first one is called an imaging satellite. I'm sure you're shocked when I tell you that that takes pictures of Earth or images of Earth. Those images can be used by our military. If you've ever watched any TV shows that have military stuff on it, NCIS or something like that, you can see that military does use it. They get some good pictures. Meteorologists, even Google. You ever Googled your house? Man, you can see all my stuff in my backyard. It's weird. Oh, sorry, back up. The second kind are communication satellites. Those are used to communicate. They send and receive signals. Use them for television, telephone, radio, all that neat, wonderful stuff. And then there are navigation satellites. That's the third kind. A lot of us have become very dependent on those navigational satellites. We like our GPS. I don't have to carry a map around anymore when I go somewhere. Lordy, I remember trying to read maps to try to get someplace, and it was like, okay, I'm going to take this road to here, and then, oh crap, I need to change maps. Yeah, what a pain in the butt. Okay, now I got my map in my car on my phone. Craziness. The last kind of satellite is the International Space Station. It's actually considered a satellite. It is the largest human-made satellite orbiting our planet. It's humongous. This is a place for humans to live while they're doing research and experiments in space. It's not just a United States thing. It's used by several different countries at the same time. There's US up there, there's Russia up there, Turkey's been up there, China's been up there, England's been up there. There's all kinds of countries have been up doing experiments. And they'll go up and they'll live for a month or two and then they'll come back down. The speed of a satellite determines what kind of orbits it's in. International Space Station, you probably can't see it, but the red dots that are right there really close to our planet, that's the International Space Station. It's in a very low, very close to Earth orbit. Imaging satellites and weather satellites are put into a little bit further out in what's called a low Earth orbit. That blue, that colored in blue there, they could be anywhere in that blue area, is a low Earth orbit. A medium Earth orbit, are we good? Can I make this go away or not? Nope, okay. Good? Low Earth orbits are perpendicular to the spin of Earth. So low Earth orbits, Earth spins east to west. Low Earth orbits go north to south.
I gotta go to the bathroom.
Medium Earth orbit is this yellow area. All of this yellow area is considered a medium Earth orbit. GPS satellites usually are put here. And so we've got lots of space to put GPS satellites. Are we good? Then there's that, see that black dot all along here? Around on the outside, you can barely see it down here, but you can see it better up at the top where it's lighter blue. This is what happens when satellites move at the same speed as Earth rotates. That means that it stays in the same position over Earth's surface. It's called a geostationary orbit. Geo means Earth, stationary means same. So same place on Earth, it's always going to be at the same place. Communication satellites, so our television satellites and things like that. Your cell phone satellite that goes with your cell phone. All of those are in geostationary orbits. We want them in the same place. From 1945 to 1991, the Soviet Union and the United States were in a state of almost constant conflict. We called it the Cold War. The United States was always worried that the USSR was going to, or the Soviet Union was going to bomb us, and they were always afraid that we were going to bomb them. During this time, we competed it to explore space also. The United States, of course, was always afraid that the USSR was going to get to space first, and then they were going to use laser beams to kill us all from space. Right? I'm telling you, that's what people used to think. Okay? We called it the space race. And the USSR were the first people to actually put satellite into orbit. They beat us. They put Sputnik 1 into orbit. It was only 58 centimeters. It was only 22.8 inches across in diameter. That means it was less than 2 feet big across. All right? And it only weighed 184 pounds. It was tiny. It had these 4 antennas like this that actually sent out radio signals, and those radio signals could be picked up with anybody who had the equipment. My father-in-law was a ham radio operator. It was just a amateur radio operator. He had a setup downstairs and would listen to this for hours. Sputnik 1 orbited the Earth in a low Earth orbit about every 96 minutes. It would make one trip around the planet in 96 minutes. It did this for 3 months, and at the end of that time, it had slowed down enough that it couldn't maintain the orbit anymore, and it descended into our atmosphere, and it burned up in the atmosphere because of all the friction. As I said, Americans were now, since they had this thing that they shot into space, well, that must mean that they're developing bombs too. And so we were afraid that they were going to win the arms race also, which meant to many people, including, I remember my mom telling me stories about this, that they were afraid that the Russians were going to just come and overrun the United States and kill everybody and take over. November 3rd, 1957, they put Sputnik 2 into orbit. It carried the first animal into orbit. It was a poor little dog named Laika. It was a stray dog that they found wandering the streets in the USSR. They trained it as an astronaut and put it in the capsule and sent it into space. However, there was no plan to bring it back. They assumed it would die at some point, and it did. And depending on who you ask, Laika only survived 5 to 6 hours, up to 4 days is what many people say. Many people say that he died after 4 hours because he had a heart attack because he was so afraid. Others say that he survived 4 days and then basically overheated because there was a malfunction in the air conditioner in the capsule, and so he overheated and died from heat stroke. It stayed in orbit until its battery ran out, and then its orbit also decayed, and it re-entered Earth on April 14th, 1958. Broke up and sent parts all over the place when it broke up. Do what?
Eating the dog?
Probably. Because if it broke, the dog would have just burned. It would have been dead, so.
Yeah, but that's so long.
I know. Now, nowadays they couldn't have gotten away with that. They could not have gotten away with just sending a dog into space without a plan to bring it back. Sorry. America's first satellite, Explorer 1, was launched on January 31st, 1958. Vanguard 1 was the second U.S. satellite. It was sent in March 17th, 1958. So yes, there were 2 of them. And then they finally established NASA, National Aeronautics Space Administration. President Eisenhower and Congress got that established later in that 1958. Are you good? Didn't hear no. May of 61, President Kennedy challenged Congress to fund NASA because he said we should be the first person on the moon by the end of that decade. And we did. By July 20th, 1969, it was close. We sent up Apollo 11, and Neil Armstrong and Buzz Aldrin became the first humans to set foot on the moon. The last manned mission to the moon was Apollo 17 on December 17, 1972. There have been other countries to send missions to the moon, but the United States is the only country that has actually put a man on the moon, or a human on the moon. Is that all of them? Are there still more?
Yes.
Okay, I will finish the lecture, and you can finish notes tonight, or I will put them up tomorrow, okay? See you, love you, bye.
Am I gonna get kind of tardy even though my bus was like really?
The United States and the USSR have both sent probes to other planets. If you don't know what a probe is, a space probe is an unmanned spacecraft that's sent to collect data by flying near or landing on an object in space. So, like, we sent them to other planets, we've sent them to the moon, we've sent them to look at asteroids and comets and things like that. Pioneer and Voyager are two of the missions that were sent to outer space. They are still going. They've been there for several years. They're still traveling. We have lost communication with Pioneer 10. But the two Voyager missions we still have contact with. The Voyager missions have actually moved outside of our solar system and are actually into interstellar space now. Okay, so that is all of the notes for today. Make sure that you understand them. If you have any questions, don't forget to send me an email, and we'll continue from then. Tomorrow you have the study guide over this section. Then on Thursday, we will probably lecture over the last section. Friday will be a makeup day. Monday, you will have the study guide over the last section. Then we will review for the test, and the test will be next week. Have a great rest of the day.